Howdy, this is your friendly neighborhood physics teacher here to go over horizontal projectiles. Now, remember, horizontal projectiles is when something rolls off or starts going horizontally at the very beginning. So let's say we have a ball here, a table. And for some reason the ball rolls off the table. So at the very beginning, it's going in the horizontal. Then it starts making the normal parabola. So in the horizontal projectiles, we only look at half the parabola. Now, a couple of key things to remember is at that very top, our Vy initial is 0. Our Vy initial is 0. And it's because it's still just moving in the horizontal at the very, very beginning. And as Vy goes down, your Vy is going to speed up. So your Vy is going to speed up until, of course, it hits the ground. Now, what's causing your Vy to speed up? Very good. What causes it to speed up is our acceleration due to gravity. Now, your acceleration due to gravity, since we're on Earth, is negative 9.8 meters per second squared. That negative is just telling you direction. That negative is just telling you direction. And since it's negative, that direction is down. That direction is down. So that's why your velocity in the y is speeding up. Another thing to remember your velocity in the x. Your velocity in the x is constant or uniform. Uniform. What that means is any point on this parabola, your velocity in the x is going to stay the same. Your velocity in the x is going to stay the same. Your velocity in the y is the only thing that changes. Your velocity in the y is the only thing that changes. So, now, let's, before we do a practice problem, we're just going to move that down. Let's look at some equations. So, in the y direction, so remember, in the y direction, go back to your graph. So y direction will be your y-axis. So anything that's going up and down will be your y direction. Anything that's going left and right is going to be your x direction. So your y is vertical, your x is horizontal. Y is vertical, x is horizontal. So some equations, let's look at some equations. So in the y direction, we have your Vy final will equal your acceleration due to gravity times your change in time. And a lot of times you can just think about that it's just time. If you remember, that looks a whole like the equation we've already seen. Our Vf equals Vi plus At. Those equations are very similar. We just don't have an initial velocity in the y, so that goes away. And our acceleration is gravity, so we just add it. We just change the A to G. Next equation. We have our velocity in the y final squared equals our 2g delta y. And again, that looks a whole lot like our original equation that we have seen before, plus 2a delta x. So again, we don't have an initial velocity, so it goes away. Our a is acceleration due to gravity, and we're dealing in the y direction, so our x turns into a y. We have one more. Delta y equals 1/2 gt squared, and that's modified from our original equation here. Again, we're in the y direction. Our a turns into a g, and we don't have an initial velocity. So those are our equations in the y direction, dealing with the horizontal. We only have one equation in the x direction, and that is our delta x equals our vx times t. That's it. And that is, there's nothing modified. That is the original equation that we did a triangle for. So delta x v t. So that one you have seen before, and that one's not even modified. So now let's do a practice problem. And remember, I'm going to kind of use the guess method to help us out here. So it says a ball is kicked horizontally at 8 meters per second off of a cliff. So it's kicked horizontally at 8 meters per second off a cliff of a height of 80 meters. How far from the base of the cliff will the ball hit the ground? So I just highlighted some key things. So horizontally and meters per second tells us that is our velocity. So we know that this is going to be our velocity in the x direction. Height, that's in the y direction. So we know that's going to end up being our delta y. And far from the base, we know that what we're looking for is our delta x. So let's kind of draw it out. So we have our cliff. We have our ball on the cliff. And it's launched. So we know our delta y is 80 meters. We're looking for our delta x, and we know that at the beginning, our velocity in the x is 8 meters per second. But don't forget, there are always hidden givens. Let's come back here and look at our drawing. Come back here and look at our drawing. Some hidden givens. Remember, our velocity in the y initial is 0. That is a hidden given. Our gravity is negative 9.8 meters per second squared. That is a hidden given. So we can write those down. So our Vyi equals 0 meters per second, and g equals negative 9.8 meters per second squared. So our two hidden givens. In a horizontal projectile problem, those will always be hidden givens. So now let's see what we're looking for. So we're looking for our delta x. So let's look at our equations. We only have one equation that has delta x in it. It's our little one over here. So we can write out delta x equals vx times time. So we're looking for our delta x. We have our velocity in the x is 8, but oh no, we don't have time. So, but remember from our notes, what affects time? Height. Yes, very good. Yeah, don't forget, height. Effects. Time. So if you're missing time, you can go to your y. So let's look at our equations and see which one has height and time in it. Well, this one has height, but no time. Oh, we have height and time, and we know gravity. Woohoo! So we know we can use our delta y equals 1/2 gt squared. Our delta y is 80. 1/2 g negative 9.8. Now, the ball is falling down, right? It's going in the negative direction. So technically this 80 is going to be negative, because remember, it just tells us the direction. It's going in the negative direction. It's going down, so it'd be negative. And we're looking for t squared. So we do a little math here. So we get a negative 4.9. We divide both sides. Now this is a key thing. I was watching people do their work. They were trying to add. It's being multiplied here, so you have to divide. You get t squared equals, let me pull out my handy dandy calculator just to make sure I know I'm doing that math. So 80 divided by 4.9 gives you 16.33. You have a squared, so you have to take the square root. So you get time equaling 4.04 seconds. Now we can take this information, bring it up here. So 4.04, we're able to find that the ball will hit 32.32 meters away. We were able to figure out our problem. So again, dealing with horizontals, you're going to be doing two parts. So you'll either start with the x and go to the y, or you're going to start with the y and go to the x. So let's do a problem that we start with the y and go to the x. So again, we're going to stick with the same kind of issue here. We have a ball that's rolling off a cliff. Let's say that the velocity in the x is 10 meters per second. The distance it traveled is 100, I like easy numbers, meters. And we're looking for how high that cliff has to be. So don't forget about your hidden givens. Don't forget about your hidden givens. Your VYI is going to be 0, and gravity is going to be negative 9.8 meters per second squared. So we're looking for our height. So let's look at our equations and see what we can use for our height. So that first one doesn't have height in it. Second one has our height, but we don't know our final. So it looks like we're going to be using our third equation. Keep going. Come on. I just love technology. So we'll be using our third equation. Our delta y equals 1/2 gt squared. We're looking for our delta y, 1/2 negative 9.8. Oh no, we don't have time. So, but we do have our delta x and our vx, so we can use our only equation in the x direction to find time. Solve for time. Being multiplied, so you have to divide. So it takes 10 seconds. Once you get that information, you can bring that up here. So 10 squared. So you end up getting 1/2 negative 9.8, 10 squared. The height has to be negative 490 meters. Now, that negative just tells you the direction. So to reach the bottom, it has to go down. So if it's asking for height, you technically could just leave it as 490. But just know that when the ball falls, it's going in the negative direction. And that is our answer. So that's the horizontal ones are pretty straightforward, nothing too fancy. If you have any questions, let me know. I hope you have a wonderful rest of the day. Bye.